Welcome back. Previously we have discussed about how to find the table value of the z, and let us discuss some of the application level cases with regarding to that. Next case, find the probability values. Here some of the cases of probability with regard to the normal distribution situation is given. A probability with minus 1.78 less than z less than 1.78. Likewise, I think before we going to the application level of this same question, let us discuss some of the situations which we have discussed previously in association with the normal bell curve. We have discussed that. Before we going further into these questions, let us discuss that. Then we will get a clear idea about the concept which we are going to do now. In the previous session, we have learned how to find the value of z on the base of table value. You have on the base of the equation x minus mean divided by standard deviation, you will get the value z equal to 1.25. And on the base of table value, you have represented that 0.3944. It is represented as 39.44. And with another example, you will get a clear picture regarding that. And let us come back. Okay, in the last session we have learned how to find the value of z. You have found the value of z using the equation 1.25, and how you are going to represent on the base of the table value. And we have learned how to find the table value of 1.25, and we have learned about 0. See, 1.25, here we have got 0.3944, and in case of 1 you have got 0.3413. Let us deal the first one. The value of z is 1.25. On the base of table you got 0.3944. I think you are clear about that. And if you multiply it with 100, the same can be represented in 39.44. Okay, see, this is actually a pictorial representation of a very lively standard normal bell curve. See, this is actually a pictorial representation, animated representation of the graph. See, our value was 1.25. See, you can see that the value is 1.25, and it is a positive value. We haven't discussed about negative value until now. So here, see, z value it is showing now, it is minus 0.22. See, within the yellow color patch you found that 1.25. See, let us take 1.25. Now is 0.45, 3, 5, 6, 6, 7, 79, 80, 90, 1.1 point. Yes. See, if the z value is 1.25, that means the area under the study or under the normal curve means from 0 it covers around 39.44% of the normal bell curve. That is the meaning of this 39.44. So if you are asked to find what is the area under the study, means your value 1.25, that represents 39.44% from 0 to the whatever the side. Here it is 1.25, so it will be plus 1.25. If it was a negative value, similarly here will also the value will be, see, same value 39.44. The thing is, it is minus 1.25. Here, when it comes to here, it will be plus 1.25. That is the difference. So this is actually a live representation of a normal curve. If you search Google, you will get a example case like this. It's a very really funny method to find, easiest method for understanding and representing the standard normal curve distribution. Similarly, if you go through second example, if the z value is 1, since there is no negative, let us deal with right side. So z value is 1. 1 means going on 6.6, 0.8, 0.9, 1, 1. Yes, 1. See, 34.13. See, the same has been computed mathematically. And why I am showing the picture is this: you need to represent the state, whatever the interpretation or analysis, you have to show the same in the form of a normal curve, just like this. You have to show in the examination. It is better to show. Sometimes in the question they may specify to show in a graphical form. In that case, you need to use a freehand curve and represent the same in the form of a picture. It doesn't mean that you have to go exactly as per the scale and numerical approximation. You just figure out a normal handy curve. So this is how you have to represent in a normal curve. And this is a concept of representation of a normal distribution curve. So this is how you have to find the values and percentage. So that is the meaning of this 34.13% or whatever it is. And sometimes in the next earlier I have shown some questions regarding 1, 2, 3, and before we going further we have mentioned that we will discuss about this normal curve and percentage representation. After that we will come to that. See, in that problem it will be quite confusing, but don't worry, we will overcome that. In that case you will be given two values. Sometimes both values will be positive, sometimes both value will be negative, or one may be positive and other may be negative. The thing is you have to find this value, this percentage or area on the under study. What is the area of the distribution under the study? That is the concept. Here in the case the area under study is 0 z equal to 1, that represents 34.13%, or it can be represented as 0.3944, and it can be represented in a graph like this. So it's a very easiest method for identifying this. If you search Google you will get. Let's come back to the case, then you will get the clear picture regarding that. So next case, probability with regard to the normal distribution situation, where you are given 5 kinds of questions. We will deal with each one separately in detail. So here first question is like this: what is the probability that if the value given under study is minus 1.78, which will be less than the z value, and that value will be less than 1.78. The meaning of the sentence is one is positive and another is negative. Z is the one that is in the middle, and usually the value, this z value will be greater than whatever negative value, and it will be less than whatever positive value under the study. So you have to find the area under the study. So you need to find, first of all, minus 1.78. As per the table you have to find the value. So the difference is, as per the table, minus 1.78 is 0.4625, and as per the table, plus 178 also will be 0.4625. Remember, if you come across a question where 1 is minus and 1 is negative, whether the number is the same or not, 1 is minus and 1 is negative, you need to add. So the area under study is 0.925. See, this is how you can represent the same. Earlier I have shown a graph in which I have mentioned that if you search the Google you will come across a case like that. This is just like a bell diagram, and here 1.78 will be a point that will be comes towards the left hand side of the graph. So here it will be 0. It will become somewhere around here, that is 1.78. The value as per the table, here 1.78 given in the question, you have to check the standard normal curve with regard to the x variables, and in the table you will get the value 0.4625. Similarly, for 1.78 definitely the number will be the same. Even if it is minus or plus, it doesn't matter, the numbers will be the same. And the question you are asked to find the area between these values. So area between these values means this area and this area. So what is the measurement of that area? If, for example, if this area represents 5 centimeter and this area represents 5 centimeter, what is the total centimeter of these in between these points? What is the answer? 10 centimeter. The same concept also followed here. See, 4.625 is the measurement of that. Measurement means from this point to this here, as per the table value it is represented as 0.4625. Similarly, here also it is 0.4625 because right side represent positive value or left side represent negative value. So if you add these two sides, definitely you will get the total area of that particular area or particular points. In between these points, there is an area of 0.925. Remember, when the values under the studies are on the either side, that means one is negative and one is positive. In that case, only in two different either sides will come. One is positive and one is negative. Remember, add these two values. That is a logical trick with regard to that. So this is how you have to deal with. And next one is when the probability is given as 1.52 is less than z is less than 2.101. You may think that here both are positive and the values is like this. The meaning is that these two represents positive values. So positive values means they are shown in the same side. Same side means right side of the bell diagram. So it can be written as, first of all, you need to write like this: P of 0 less than z less than 2.01, because here this value is the biggest value, so it is represented like this. Whenever there is a positive value, the flow of signs is shown like this: 0 represented by z. Here the value of z definitely will be greater than 0, and the question 2.01, that is also greatest value, so let it be like that. Minus, see the difference is here we have used the plus sign, here we have used the minus sign. So in case of minus, P of 0 into z greater than 1.52. So you may find, in the initial glance you may find it confusing. Here in the first case we have used on another side, here it is on the other side. How we are going to deal that? It's very simple. Whenever you are representing a negative value, first of all write down the negative value, a less than sign, z less than 0. Whenever you are dealing a positive value, see this one is positive, this one is positive, this one is positive. It's very simple. Show the representation opposite to this value. See, 0 less than z less than 1.52, just like that. That is the representation of a positive value and a negative value. At first you may find it confusing because I think it is because of the complex representation and accumulation of all these numbers and signs in a small page. That may be the situation. Don't worry. So what is the area under the study in between these values? How you are going to find it? And you may think that here we have used minus, here we have used plus. What is the logic behind that? The thing is, see, 2.01, here whatever the biggest value, that is shown first. So 2.01 is greater than 1.52, so 2.01 minus 1.52, that was the concept. 2.01, the value is 0.4778. So 2.01 is from here to here, it is 2.01, so the value is 0.4778. Okay, next one, 1.52, that is 0 till here, that is 1.52. With the graph I will show the representation of each of these three cases. So 1.52 here, as per the table, the value is this one. So why we have taken the subtraction sign instead of a plus sign? You are asked to find the area between two values. Here our two values are on the both sides of the graph. So in order to find the area in between this, just add the values. And the values mean from 0 to positive value is represented as 0.4625. From 0 to here representation is as 0.4625. We just add it together. But here you can see that both lines are on the same side. So you are asked to find the difference between, or the area between 2.01, this value and this value, that is this smaller value. How we are going to find the difference? Because from here 0 till 2.01 is represented as 0.4778. From 0 to 0.152 is represented as 0.4357. So in order to find the difference between these, or the area between these two values, you need to deduct this one from this. And the logic is that whenever you are dealing with the values having similar signs, or on similar signs means values on the same side. If the values are on the same side, they will have similar sign. That is the meaning. If the values are on the same side, or the value positive, both numbers are positive or negative, you need to take the difference. With a simple example, I will explain. From this point to this point, the measurement is 10. From this point to this point, the measurement is 6. I want to know the difference between this point and this point. How you are going to take? Total difference is measurement is 10. From here to here it is 6. So what is the difference between here? It is 4. That is the logic behind this one. Since it is represented in a numerical forms like decimal, huge decimal forms and numerical terms, you may find it confusing and tricky. Don't worry. I hope you understand the concept. And next one. First one is we have dealt with different signs. Second one we have dealt with same signs. Next one, let us deal with similar signs, but both are negative. How we are going to deal that? In case of both are negative, it is almost similar to the pattern which we have dealt in case of this previously. See, here both are positive, so we have taken subtraction in between value. The same thing is also followed in case of negative values. If both numbers are negative, which one is bigger? 0.1525. 0.1 minus 0.152. See the signs to the opposite side. When we are dealing with a negative value, it's the opposite side. Minus P of minus 0.75, opposite sides. So it can be represented in a graph like this. See here 0.152 is represented as, from here to here is represented as 0.152. See, the value of this minus 0.152 is, as per the table, is 0.4357. Let it be like that. Next one, minus 0.75. From here to here is represented as minus 0.75. The table value as per the minus 0.75 is 0.2734. And you are asked to find the area between these 2 points. So the area between these 2 points is shown in this shaded portion is represented that area. So how you are going to find the value? It's very simple. From here to here the value is 0.4357, and from this point to this point is 0.2734. But if you take the difference between these 2 points, then definitely you will get the area of this particular shaded region. That is the concept. That is also shown here. So this is how you have to deal with a normal distribution situation where values will be given either positive values or negative value, or one may be positive and another may be negative. So this is how you have to represent the same in a graph. And finally, this is another case, and here this fourth and fifth one is will be showing in a computation. See, probability that the z value is greater than 1.8. So there are no other values. That means whenever you are dealing with a single value against 0.5, because here the z value is 1.8. 1.8 means definitely it will be a value within the right side of the curve, and there are no other values. So you need to take the measurement of the area. How you are going to find the measurement of the area if you don't know the value of the next figure number? So whenever you come across such a question, it means we already knew that the measurement of one side alone is 0.5. So just take the table value of 1.8. As per the table value, 1.8 is 0.4641. Remember, this value, table value of this one, whatever the number under the study, it will never go above 0.5 with regard to one side. With regard to one side, if you are dealing a positive side, it will never go beyond 0.5. That was the concept I have mentioned. So when you are dealing 1.8 and we don't know another value, so you need to take the difference between 0.5 minus 0.4641. So you will get 0.0359. I will show with an animated graph right now after the explanation. Just like that, another case here it is probability with regard to z less than minus 1.5. So since there are no other values to check the measurement, we can assume that it can be compared with the measurement of the entire side. So entire side will be minus 5 minus 0.4332. So you will get the area of the measurement between 2 points 0.0668. So this is how you have to deal with the normal distribution case. I hope you understand the concept. With the graphic animation, I will explain the same case right now. So these were the cases which we have discussed now. See, this was the standard normal distribution table graph. See, first one minus 1.78. See, if you go through it, you can see that minus 1.78 is represented as this is the issue with regard to that. It's very difficult to pinpoint the point. Okay, 46.33. That is represented as 0.4625. And here it is 1.78. If you exactly pinpoint that, we will get the exact 46.25. Actually this was the value 0.4625. So from this point to this point, the area value of the area is 0.4625. Remember, because if I am showing the next one, this color will be gone. So from this point to this point is 0.4625 or 46.25. So I am going for the next one, 1.78, positive 1.78. So it will be 1.78 will be, see, here also value will be same. So in the question you are asked to find the area that is covered in between 1.78 minus 1.78 and plus 1.78. So if you add these two areas, you will exactly get the value as 0.925. That was the concept I asked in the question. Okay. Second one, 1.52 and 2.01. Both the numbers are positive. So whenever the numbers are positive, that means they will be on the same side, one side. If it is positive, the both numbers will be here. If it is negative, it will be represented here. When the both numbers are same sign or the both comes to the same side, you will take subtraction. See, 1.52 and 2.01. You subtracted the value of 2.01 minus 1.52 because 2.01 from here to here, 2.01 is represent 2.01. See, 47.78, otherwise known as 0.4778. I hope you know how to find how you got 47.78 and what is the meaning of 0.4778. We have explained that concept during the computation of table value. Okay. From here to here, the value is 0.4778, and next one is 1.52. 1.52 is almost here. See, so from here to here, the value is represented as 0.4357. But at the same time, from here to 2.01, here it will be 0.4773. So you are asked to find the difference between 2.01 and 1.52, that is the smaller area. What is the measurement of this area? That was the question asked under the explanation. So how you are going to find it? You need to deduct this number for 2.01, then you will get the value of the smaller area. That was the concept. See, that is represented here. Difference between these two areas. When you are dealing with the numbers within the same area, you need to take the difference. Then only you will get the area of the in between those two values. If the numbers are on the both sides, you need to take the addition. You have to add together to get the same values. And similarly, minus 1.52 and 0.75, it is almost similar to that. 1.52, it is almost here 1.52. See, 43.57, here it is 0.4357, and out of which you have to deduct 0.75. See, 0.2734 point. So out of 1.52 you need to deduct this shaded area so as to get the difference between these 2 points. These 2 points means 1.52 and this point 0.75. That is why here also we have to take the subtraction between these two values. And finally, see 1.8. So whenever you come across 1.8, how you are going to take the difference between, earlier you have got minus 1.52 and 0.75, take the difference. Same values also take the difference. Different values you take this add. Here only one value. How you are going to find? So that case, I have mentioned earlier, one side is represented by 0.5. This measurement is represented by 0.5 and this side also is represented by 0.5. So 1.8 means from here onwards 1.8. See, almost this much area is covered under 1.8. That represents 0.4641. See, the entire measurement of the, so you need to learn the difference between this area, because here you are given only one value. So we are taking the difference between 0.5 and 1.8. 1.8 means 0.5 and whatever the table value as per the 1.8. So 0.5 means from here to till this point is 0.5. So from here to here it is 0.5 and from here to this entire colored area, this area is 0.4641. So how we are going to find the area, that is area which are not given any blue color? You need to find the area of this one. So it's very easy. We know that the total value of this side is 0.5. Out of 0.5, if you deduct 0.4641, here it is represented in percentage, the table value is 0.4641. If you deduct that, you will get the area of the remaining portion. That was the concept which we have done now. And finally, next one 1.8 and another question was minus 1.5. Similarly, see minus 1.5. See, the value is 0.4332, that is represented as 43.32. So in this case you need to take the difference or whatever the area in between numbers under the study. Here the one number is 0.15 is, here only 1.5 is given. So the next number, it is assumed that if one number is given, the entire value of that side is 0.5. So if you deduct that number from 0.5, you will get the area of this remaining portion. See, this was the remaining portion. You have to find the area of this one. This is how you have done the concept. So I hope you have understand the concept, and remember the main concept regarding area of a half curve. Half curve means this one. This from this to this is known as half curve, is represented as 0.5. So if you want to get the tail area, this is known as tail. See, just like a tail of an animal, it is going like this. So if you want to get the area of this tail area, you need to deduct whatever the number from 0.5. That is the concept which we have done now. I hope you have understand the concept regarding the normal distribution. Just go through all these areas. We will discuss about further cases with regarding to that, and please let me know if you have any queries. I am very pleased to help you with regarding to that, because actually this is the most difficult area under the subject, and you need to be very cautious while dealing with studying and understanding these areas. I hope you understand the concept. We will discuss about further cases in the next one.